Hey everyone, thanks for coming in here. I guess these are the security people? Nah. But that's okay, because this panel's not really about security people. It's about what the whole mythos, glass swing, vulnerability apocalypse, whatever you want to call it, what does it mean for platform engineers? What does it mean for ops? What does it mean for you? Right? Because I think it's going to have a profound impact. My name is Alan Schimmel. I am the CEO of TechStrong. You may not know TechStrong, but maybe you know DevOps.com, Security Boulevard, PlatformEngineering.com, TechStrong AI, IT, TechStrong Semi. We've got a lot of TechStrong stuff. We do a lot of video. But I wasn't always a media person. I actually have about 30, 35 years in venture-backed startups, mostly in security. And I've seen, look, I was here for the .com. I sold my first company into the .com space. So I've seen waves come and go, but nothing like this wave. I've got some really experienced people on the panel, not old, really experienced people on the panel. Let me introduce you to them. On my far left, we've got Drew Gutstein. Drew, if you want to just say a few words about yourself.
Hi, everybody. Drew Gutstein, currently independent security consultant, Gutstein Security Works, GS.works. My last full role was as CISO at Hudson River Trading, a high-frequency trading firm based here in New York, big global company. And before that, working for Google in Google Cloud Governance, so doing kind of FedRAMP and a lot of authorizations, security regimes, that kind of thing. Prior to that, for about 20 years, worked at Goldman Sachs doing all kinds of electronic trading, environment, pretty much everything I could possibly figure out how to do there. And now I'm really excited to be here. I can't wait to talk even more about AI with you guys. I'm sure you're all sick of it.
Thank you. Thanks, Drew. Thanks for coming in. Between Drew and I is my friend Ian Amit of Gombach. And Ian, if you wouldn't mind.
Sure. Ian Amit, co-founder and CEO at Gombach AI. Been running Gombach for the last 3 years. Built it essentially on the heels of my experience as a CISO. Pretty much like Drew, I was a CISO for a couple of public companies, multi-billion-dollar multinational organizations. Before that, unlike Drew, I actually did proper cloud at AWS. So I was responsible for securing the Nitro instances using the Amazon hardware all the way down to the chip level. Ran AppSec for Amazon and a plethora of other roles in security. Basically anything you can break, I probably broke it a few times.
Thank you, Ian. Thanks for coming. To my left is my good friend John Willis, who some of you may know of John, but John, tell him about yourself.
Yeah, I'm old as dirt, right? Now, I've been doing this, I think, 45 years. I stopped counting at some point. And I think the universe, when people ask me, what do I do? The universe is trying to yell at me to retire, and I'm fighting back as hard as I can. I was considered founder of DevOps. I co-wrote the DevOps handbook. I've written like 15 books. I sold the company to Docker. I've done a lot of stuff. Over the last, probably from 20, I've been really interested in, GPT-3 got me pretty interested. Vector databases got me more interested because I realized we could sort of moderate the hallucination. I wrote a book about the history of AI called Rebels of Reason. And today I focus, because I'm the ops in that equation of DevOps. I've been ops my whole career. And I worry about the brand. So I look at technologies over 5 decades, and I get concerned. And I was mildly concerned when AI exploded. I think in the grand scheme of things that don't matter, I think I got first use on shadow AI, but I am incredibly concerned now about agentics and basically the concerns there, and and not just the vulnerabilities, but all the things that we created the blast radius beyond what humans can comprehend.
Yeah, hi, I'm Mandy Walls. I'm the patsy on this panel, I think maybe. I am a developer advocate currently at PagerDuty, so on the sharp end of everyone who wants to build an AI SRE. And prior to that, I was at Chef for a long time, with John for a while, and before that, I was an operator at AOL. So for those of us with the gray hair in the room, I used to run the big systems for America Online and all the flagships there. So that is my history, is always on the operating side as well.
All right.
Ops, that's security.
That's right, fight.
Yeah.
Ops security, okay. So I assume everyone here knows when we say mythos, what we're talking about, yes? Okay. As someone who's been in security for 25 plus years before it was called cyber, we've had a vulnerability remediation problem for every single one of those 25 years. We never were able to remediate, and not just patch, there's more to fixing vulnerabilities than patching. We've never been able to remediate all the vulnerabilities we found. That was before Mythos, right? We called it technical debt, and we've never really dealt with the issue, because it's a funny thing, and I'm sure all of us here have dealt with this. Security guys found, or security people, excuse me, security people found vulnerabilities, but they didn't fix them.
Yeah.
Who fixed the vulnerabilities? Ops people, for the most part, help desk people. And that friction explained a lot. Drew, you've been dealing with this for 25, 30 years, right? Between Goldman Sachs and so forth. Ian, I know you have for longer. So what's changed now with two things? Number one, AI, but number two, platform engineering.
I guess I'll start.
Yeah, go ahead.
I first came across this when I was at Google. One of the responsibilities I had was working with the compliance teams on our monthly POAM reports. Anyone who's ever done FedRAMP before may have heard of this, but this is where we need to submit all our known vulnerabilities to the government. The government then picks up to 5 that need to be remediated, and if you have more than 5, you can lose your authorization. That's like the official rule. And it's absurd when you think about like a scale of Google, where like we can't even fit the number of vulnerabilities in a spreadsheet, let alone like have the government figure out what to do with those. And it was obviously at a hyperscale a completely unworkable problem, but we applied what's now actually fairly common, that sort of like enrichment around vulnerabilities, focus on the things that are exploitable, focus on the things that are exposed, downgrade, downgrade, downgrade until you get to 5, right? And it's really, I think industry-wide, we've all known that kind of vulnerability patching programs are not effective, right? And I think what's happening now is the development of Mythos and the attention that this increased vulnerability environment is causing is allowing people to realize how broken the existing process already was. So I don't see this as really like a change per se. I think this is sort of a recognition of a problem that's been kind of brewing within the security world for a long time, right? And this is this drift of security controls that eventually become compliance, check your box exercises, and you lose the kind of primary purpose. So we're going to get back to that. We're going to get back to actually curing things, and I think that's actually something that I'm really excited about.
From my perspective, I have a slightly different perspective. I would say that the previous, pre-Mythos or pre-AI situation was sort of stable. And the reason is that the rate of discovering vulnerabilities was fairly constant, and it was bound mostly by human innovation, by capabilities that researchers had to find vulnerabilities, string them together, exploit them. That was still a long process. And defenders, yes, they were behind, they were overwhelmed, and they had to prioritize and kind of pick and choose what to fix. But that was a sort of stable condition. Now, what changed for me with the introduction of AI, and even before that, we started seeing more automation around automated vulnerability finding. We started seeing more automation around fuzzing. That was, if you ask me, Mythos is sort of a glorified fuzzer, a really smart one. But it really shortened the time that it takes a researcher to find vulnerabilities and start pushing them. Now, that really tipped the scale. And the thing that puts this out of balance is the fact that as much as Mythos is a great innovation and capability, it is not equal on both sides. It's really good at doing the rote, fuzzing, inaccurate, kind of iterative process that's required for finding vulnerabilities. However, when you try to put it in the context of a defender, it fails. It can automate a lot of the existing processes that we have, but it cannot automate the bulk of where the bottleneck is at, which is the human trying to figure out what's the context and how to exactly fix something. And Alan said it before, it's not just patching. It's understanding the implications of doing something in production, as you all know, and what does that mean? You might fix a vulnerability, but break prod. That's not a good thing. I've seen that a few times. And I think that's the imbalance that I've seen with Mythos. It's sort of a double-edged sword. And by the way, ask yourselves, and that's what I've been asking people, Project Glasswing. First and foremost, how many CVEs came out of it? Anyone knows? No, because it's 0. There's no validated public vulnerabilities that were published based on it. And by the way, if Mythos was so great under Project Glasswing and had access to the source code, why didn't it produce the fixes associated with it? And the answer is as simple as that. It's an iterative process. It's non-deterministic, which means the fixes couldn't be validated. And that's where the imbalance kind of translates to me, and that's what I think that we need to fix and find solutions to allow defenders, to allow platform engineers and DevOps people and security people to keep up with the imbalance that was created by Mythos.
Yeah, so what I want to say is, excuse my French, but findings have always been bullshit. CVEs are now more than ever bullshit, because it's not a CVE. In fact, they just downgraded SQL injection from like a 5 to an 8, right? Yeah. But it's chain of exploit. It's the reasoning. And by the way, it's not just Mythos. Exploit Bench just did research that it matched, GPT-5.5 matches Mythos in the findings. So like, this Mythos is the dangerous, oh my God. Right. They're all bad. They're all scary. But what the real problem is, because I worked, for about 10 years, I did qualitative analysis of some of the largest financial institutions in the world. One of them was 10 trillion in asset holdings, right? And the thing I'd always find, and I'm not a security person, I'm an ops person, but I'd first go in and say, I want to see a list of vulnerabilities that have been open, severes, criticals and highs that have been open for over a year. And it would amaze me, the banks that you have your money in, that would have critical vulnerabilities in what they call tier 1 services. You would know what that is, right? That means it's customer facing. And guess what never happened? They never got exploited. Because the reasoning it takes to get that exploit is a very complicated chain of not just CVEs, it's misparameters, it's all, and that's the power of these models. The power of these models is can go out and just create this reasoning that humans just can't do. Even the best, Nicholas Carlini, who is the chief vulnerability scientist for Google, was hired away to Anthropic, said that Opus 4.7 is better at vulnerability finding than he is. This has got to be one of the top 5 vulnerability scientists in the world, right? So it isn't the CVEs. We got to get off of this, like the CVEs and how are we going to keep up and how do we patch? It's the complexity of the chain of exploits. And so there's some good research. It's called Exploit Bench. Is doing some really good research on this idea of chain of exploits, how you can find, again, putting SQL injection and downgrading its severity, if it exists, and there's a chain of parameters and libraries and the asset holdings of your company. That's the other thing. You just don't know what you have. I mean, I've been doing this for as long as ever. I go into companies, they don't know what they have. They use DAST and SAST to catch it at a time, but that doesn't tell the asset holding. So anyway, that's the fear I have, is that the complexity of this thing and these models are just so good at reasoning to find things humans I don't think have the capability of finding.
No, I think you make a good point there, because like
Thank you.
the way this all has worked in the past has been like we sit on the risk. And the companies are like, oh, well, we don't have to patch that right now. We don't have to worry about that right now because it's not going to go anywhere. They'll never find it, or they won't be able to exploit it, or it's behind a good enough firewall or whatever it is. And like that's going to blow that whole thing out of the water. That you cannot sit on that risk the same way, and your entire profile has to change. That is not part of these discussions yet. It's like that hasn't trickled down into the folks that are making those decisions. We've already seen things that get exploited, and it's months or years before some of our biggest companies are patching these things. You see a report like somebody got popped or whatever, and you're like, okay, well that was something that we knew was patched months ago, but you're sitting on that risk for too long. And I think that is going to change for a lot of these folks in compliance and other parts of the industry are going to have to really reevaluate what they do.
So I call this issue, though, AI scale. That's the real problem. I think Ian hit it. We had an equilibrium. There were only so many researchers finding so many vulnerabilities, and there were so many people fixing them. Now, all of a sudden, one side of the equation got 10x, 100x, whatever you want to call it. How do we find equilibrium? Well, if we added AI scale on, if you remember your math classes, right? You add something on this side of the equal sign, you got to add something on that side of the equal sign. That something is you, platform engineers, and the people who do it. You know, because platform engineer is a term that takes up there's a lot of different little things underneath being a platform engineer. You know, John and Mandy would call it ops because that's the world they come from. But we need to restore balance in the force, if you will, right? Yeah. On the platform side. And I think that's the key here. It's going to take AI. I don't think we could do it without using AI on this side. It's going to take having it built into these platforms. And so I think you got to look at the platforms you're using and saying, okay, how are we going to AI scale security? How are we going to AI scale remediation, right? What process do we set up to equal?
So Kent Beck, the founder of XP, he has, my favorite quote of him is, make the right thing the easy thing.
Yes.
And that's got to be the platform. The only thing I don't know a lot of things about how the world's going to look in the next 2 years, 3 years, 5 years. I'm absolutely certain that the way we're going to have to build that sort of the scale is through the platform. And today it's Kubernetes, tomorrow who knows what, I don't care. But the point is, it is the job of coming together between security, ops, app, and all really working on all that. I mean, I don't know how to solve the problem. Hopefully I really am retired by the time that problem gets solved. But like, I think it's going to take people in the room to make sure you get all that thinking in there and create that sort of, look up Ashby's law and it'll explain how you have to scale the sort of the balance that the platform. So we're in the right place.
And if I may be blunt, and I'm going to use an example on...
I know him a long time. He's always
I
blunt.
know, yeah.
Okay.
One of the most powerful things that a CISO can say, and again, I'm taking this from my past, is, I don't care. When faced with a vulnerability, when faced with a pen test report or whatever it is, the strongest thing you can say is, I don't care. Now, it's not just that I'm reckless and I don't really care. It's because I have people like yourself. Because I have strong ops and DevOps and platform engineering people that can reason why I can say I don't care. Why this vulnerability doesn't affect us. Because we have the right architecture, the right controls around it. And that's why I don't care. Now, the imbalance that we're all talking about only affects one side. And the reason is that AI in its current form, again, Mythos, ChatGPT 5.5, even M-Dash, by the way, which blows both of them out of the water if you really want to get nitpicky on performance, doesn't give you the deterministic reasoning ability that I have received from platform engineers, from DevOps, to allow me to say I don't care. And that's the missing piece right now.
Yeah.
You can automate a lot of the processes that lead you to it, but you cannot, it still doesn't empower you to do that at scale, at the same scale of finding and stringing those vulnerabilities. So hopefully that kind of makes sense. Yeah. Give me the ability to say, to continuously say I don't care, by you backing me up, by you telling me I've used, we've got 100 new vulnerabilities. And by the way, the rate of vulnerabilities is also increasing from the development itself. Mythos doesn't develop clean code. It develops 10x code with 10x the bugs in it.
Yeah.
And we still need you to reason around those and say, that's fine, I don't care. Because it's localized, because it's controllable.
I think, if I'm going to dump on vulnerability scanning just a little bit more, look, we know that even if we are doing a perfect job, if every known vulnerability is patched, we are still vulnerable. Totally. Right? There's 0 days. Yep. There's determined state actors. They're going to get in no matter what you do. Simply relying on a patch report was never the goal, right? It's the sort of layers of security that live under that protect you from exploitation, blast radius. What's happened with AI, and I think we spent maybe the last 2 years worrying about AI stealing IP and devaluing software, but software is already worthless. What's valuable is the platform, what runs the software. Is really where a lot of sort of if you're a SaaS company, that's what makes your money. What AI has done has really kind of exposed that trust issue, right? The trust issue being that we're all lying when we talk about our first-party software. Everybody runs second-party software, right? We don't own most of the bugs that are in our code. Right. So it doesn't matter how good we scan our code. It doesn't matter how good we do our things. There's so much more out there that we can't control. And so we need to solve this problem to really enhance the other controls that security relies on when patching fails. That's segregation, that's detection and monitoring, and what I think now is the most important control of all, and we've got some former chef people here, but declarative infrastructure. We need to be able to recover super fast because we're going to be getting popped a lot more often than we used to, right? So we need to think about how, okay, given that the risk landscape has increased dramatically, given that AI as a platform, we're still discovering how it can be exploited, it's so new, these other controls are going to be what protects us.
There's another myth that I want to hit on and interested in your input, that somehow it's going to be painful doing all this, but we're going to come out the other side with developing better code, that somehow developers using AI are going to make more secure code that's more secure, code that's better tested, code so we won't have all these vulnerabilities, because there are some people who say this, and you can agree or disagree. There's a finite amount of vulnerabilities that could exist in any given code base. And that as a result of this, we're going to have better code. I'll throw it to the panel. You guys have been around. Does this result in better code?
No, I think there is no finite, right? These are complex systems. So there's chaos theory, there's complexity theory. There is no, you could have the exact infrastructure, identical, which is impossible, between a bank and another bank, and they will operate differently.
Oh, yeah.
Right? That's complexity theory, right? So there is no finite. The idea that the reasoning can get through. But here's the thing, and I agree with you. The point I'm thinking is we use scanning and identification and finding as a latent discovery tool. Yes. We don't know what our assets are. How many people in this room have SBOMs?
Guys, we only scan because we don't have a good inventory.
But we don't know what we have. We don't find out what we might have that could cause us, what we might have a problem with.
Yeah.
But what we don't know is what we have. So we should be using AI to figure out what we have. And there are some really good tools out there right now. Graphs, James Wickett from Dry Run just did a great blog about how you can use Git history to do a call graph. Find out what you have. And like I said, my first question to you, if you're concerned about this, do you have SBOMs? And SBOMs are necessary, but clearly not sufficient. But if you don't have SBOMs, You don't know you're not even trying to figure out what you have.
And you have no idea what you're deploying into either.
I do,
Because you're
yeah.
not paying any attention to the platform underneath
yeah.
unless you are really, really good at platform engineering. And we are not
Yeah.
to the point yet where anybody is really, really good at platform engineering. And when we go in and talk to customers, like, we want to help you with incident response. You have no idea what's running in your production environment. You can't even address basic performance, let alone get in there and get something secure and know when you have vulnerabilities and when they don't apply to your systems, because you're not paying enough attention to what is in production. And yeah, I'm old enough to remember old school CMDBs, and we had disk scanners that would spike the power consumption in the data center overnight when it was scanning the disks for all the software. We don't do that anymore because we don't own the disks. But we still have to know what is out there, what we've deployed, what we haven't deployed, but within the platform to begin with, before you can even begin to think that, yes, we have addressed even a fraction of what might be vulnerable. You have no idea what you're running on.
Absolutely. Hey, one other area I want to bring up. Even if by some chance we figure this all out, platform engineers get better, the engineering platforms get better, security gets better, remediation techniques get better. You know, the theory of constraints, whether you maybe heard it in the Phoenix Project or the goal before that, it's only going to open the next bottleneck or reveal the next bottleneck beyond the remediation. What is that next bottleneck, you think? Assuming, you know, nirvana hits and we get all these things going, because this AI scale thing is like a rat working through a snake, right? And it has to work its way through.
My next book is The History of Quantum Computing, and I'll drop a stink bomb here, is when we get quantum neural networks to work, you think what we got now is scary? You can't even imagine what those machines will do.
Quantum platforms.
Just quantum algorithms.
Well, and with the models too, like, model poisoning is another place where we're going to be vulnerable to things. It doesn't take many new documents to completely collapse a model. And depending on what you're relying on that model for, then you could be really left out in some really dangerous places. So models with hundreds and thousands and billions of incoming documents, you can poison them with just a few hundred new bad pieces of data. We know a lot of the data that we have is already bad. So data engineering and those kinds of folks have a huge job to do in the future.
I want to put a fine point on that because this is really, really important. So the risk is not they're going to steal our IP. The risk is a poisoned agent is going to run rampant in our environment. I can't tell you how many calls I've been on talking to folks about their AI SOC, right? You guys have all been paying attention to the Fable 5 debacle.
Oh, yeah.
Right.
So Anthropic used the best possible guardrails that they could come up with to limit the capabilities of Mythos so they could release it as Fable. Within days, it was completely
That's the world.
circumvented.
Less than 48 hours,
Yeah.
completely owned.
The guardrails don't work, okay?
No, they're
don't
not
work.
going to.
You cannot rely on that. We need like proven, reliable controls, not guardrails. And so this is where platforms comes into play, right? There's not going to be some cool AI tool that solves this for us. These are like systems that already exist, ways of adopting controls that we already know work. The essence of the threat vector now is inside risk. This is something we know we're terrible at as an industry, right? But now that insider is your agentic developer. It's the agent in your SOC, right?
Right.
That's the insider. And so we need to be a lot more prescriptive about access controls. And I was talking about blast radius earlier. These are the controls that exist to deal with insider threat. We need to start adopting and really pushing that further. It's so important.
I got to wrap it up because this thing says 000. Listen, I appreciate the passion from all my panel members here. I knew it was a great panel. I hope you've enjoyed it. If you have questions, we're all going to be here most of the day. Please hunt us out back here. But we've got to wrap it up. Good luck. You've got a lot. As platform engineers, we've got a lot to be working on. Thank you very much.
Thank you.